So, good morning. So we were to conclude on the profitability index by checking at a question of May 2018. May 2018, question number 4, part C. May 2018, question number 4, part C. So let us go through that question for May 2018, question number 4, part C. May 2018, question 4, part C. So the question was reading that, the question was able to read that Amani Contractors Limited is intending to invest in 4 independent projects. So the following information relates to the 4 projects. The following information relates to the 4 projects. So they gave you project A, B, C, and D. They were able to give you present value of the cash inflows. Then you are also given information concerning initial outlay. Then you are given the net present value. So present value for the cash inflows for year 1, it should be 50 million. I hope it is 50. We are doing the question for the question that we had specified last time, May 2018. Question number 4, part C, Roman letter 2. Question 4, part C, Roman letter 2. So year 1, project A, it is 50 million. Initial outlay is 30, so that the net present value is 20 million. They have also given you project B, C, and also D. Additional information, note number 1. The company has a capital limitation of 90 million. The company's required rate of return is 10%. Note number 3, any surplus funds can be reinvested to generate a return of the net cash flow of 14% in perpetuity. So the projects are indivisible. Then note number 5, the projects can be combined to achieve a higher return subject to the company's capital limitation. So required advice on the optimal project combination. Advice on the optimal project combination. So when you are combining the projects, you have been told in the note number, 1, the total amount is 90 million. Capital is limited to 90 million. Then you can see project A requires 30, project B 45, project C 60, project D 40. Then they had said the projects are indivisible. When you are combining them, they should either add up to 90 or it should be less than 90. Then again, we shall be using the NPV to determine the optimal project combination. So we shall be using the NPV to see which combination has the highest NPV. So we pick that information on the basis of that. So you can combine A and B. You can also combine A and C. You can also combine A and D, because when you add them, they are either equal to 90 or less. But we cannot combine B and C. You see, B require 45, C require 60. When you add that initial outlay of 45 plus 60, it will be more than 90. So the combination that we should come up with should actually add up to what? 90 or less. Then after that, we pick it from that level. So we summarize the information in this order. we summarize that information in this order. So what you do, you will be coming up with the project combination. We shall be having project combination. We shall be having the project combination. So in the project combination, we shall also be getting the total cost. The total cost. The total cost. Then, apart from that, we shall also be able to have the surplus funds. Apart from that, we shall also be having the surplus funds. The surplus funds. We shall also come up with what is supposed to be the surplus funds. The surplus funds. Then, internal NPV, also external NPV, then total NPV, total NPV, like that. So we shall be coming up with the project combination, then total cost, surplus funds, internal NPV, external NPV, and also the total NPV. Also the total NPV. So the first combination, we could combine A and B. We could be able to combine A and B. So A is 30, B is 45. So we can combine A plus B. So if you combine A plus B, A requires an initial outlay of 30 million. B requires an initial outlay of 45 million. So when you add them together, they should give you a total of how much? It will give you a total of 75. So in the note number 1, they say that the capital is limited to 90 million. So what would be the surplus? 90 minus 75. So surplus would be 15 million. So internal NPV, we just add the normal NPV of A and B. Internal NPV. NPV for A is 20. NPV for B is 15. It will give us a total of 35. So we want to calculate the external NPV. So you can leave a space of 5 lines. We do our working. You can leave a space of like 5 lines. We do our working so that we get the external NPV. So that we come up with the external NPV. So external NPV, we want to compute for project A plus B, the external NPV from that. So we need to get the return on the investment. Return on investment. So return on investment, the question said that in the note number 4, any surplus funds can be reinvested to generate a return net cash flow of 40%. So get 14% of the surplus fund, which is 15 million. We get 14% of the surplus funds, which is supposed to be the 15 million. You get 2 points. 2.1. So you want to compute the NPV. NPV should be present value for the cash inflows. We minus the present value for the cash outflow. We want to compute the NPV. NPV will be present value for the cash inflows. We subtract the present value for the cash outflows. So starting with in the note number 3, they say that any surplus funds can be reinvested to generate return on the 40% in what? Perpetuity. In perpetuity is up to infinity. So we want to get the present value of the cash inflows. So it will be the same as the present value of the annuity up to infinity. It will be the present value for the annuity up to infinity. So it is simply the annuity divided by R. It is simply the annuity divided by R. So our annuity there is 2.1 million. Our annuity there is 2.1 million. We divide by R. R is the cost of capital. R is the cost of capital. So the question had given you note number 2. The company's required rate of return is 10%. So 10% is the same as 0.1. 10% is the same as 0.1. So that present value for the cash inflow should be the same as how much? 21. It will be 21 million. So we less present value for the cash outflow. It was the initial cost. Present value for the cash outflow is the initial cost. So initial cost is the 15 millions, the ex surplus funds. You see the surplus funds of the 15 million. That's what you invested to give you a return of 2.1 million. So you had invested 15 million so that we come up with the NPV. So that you get the NPV for that portion. So our NPV should be which way? So it will be 6 million. So now we include 6 million at this point. The 6 million at that point. So 6 million plus 35 should give us a total NPV of 1 million. NPV of 41 million. So that is now the combination of A and B. There is also a combination of A and C. You can also combine A plus C. You can also combine A plus C. So when we combine A plus C, A is 30 million. C is how much? So total is 90. So this one has no surplus funds. It has no surplus funds. So the NPV will be 20 million. Then we add C, it is 40 million. So that combined NPV is 60 million. So there is no external NPV. There was no surplus funds. There was no external NPV because there were no surplus funds. So that's now the combination of A and C. Then you can also combine A and D. You can also combine A and D. A plus D like that. So initial cost for A is 30 million. So D, it was which here? It is 40. When you add them together, it should give you a total of 70. So surplus is how much? 20. So internal NPV, okay, is 20 million. We add D is how much? So when you add them together, they should give you a total of 50 million. So you want to get the external NPV between A and D. So you start with the return on the investment. You start off with the return on the investment. So you get 14%. It will be 14% of 20 millions. 14% of 20 millions. So what should be 14% of 20 millions? So we shall have 2.8 at that point. Then you also come here, we change this one to 2.8. So it makes it be 28 millions. Then you less 20. Initial investment is 20 million. Minus 20. So we have NPV will be 8 million. So that now our total NPV will be how much? So our total must be 51. So that's now the combination between A and D. So we still have one more combination. We still have another combination. So the other combination is B and D. Because B is 45, D is 40. So that should be a total of 85. So you can also combine B and D. You can also combine B plus D. You can also combine B and D. So B require 45, the other one is 40. So 45 plus 40 should be equal to 75. Sorry, 85. Should be equal to 85. So what is the excess? The excess is 5. So internal NPV, internal NPV just add 15. So D is supposed to be 30. So it gives a total of 45. Yeah, so the surplus is 5. So get 20% of the 5. 14% of the 5 millions. What is the 14% of the 5 millions? Now, this one is the 0.75. Exactly 0.7. Yeah, so this one change to so it will be 7 million. And this one you minus 5. So the difference should be which? So this one, which should be 48. Is it 48 or 47? It will be 47. So there is no other combination which can either add up to 90 or less. Yeah, if you pick any other combination from what we have, they are going to give us more than 90, but the maximum should be what? 90. So you check this total NPV. Which combination has the highest total NPV? A and C. So we can now make a conclusion by summarizing that the optimal project combination, is where the total NPV is maximum. Therefore, select project A and C. We select project A and C. Therefore, we select project A and C. So that is now all about NP, profitability index. That was now on when we were discussing about the profitability index. So I want us now to go to the last technique. The last technique should be internal rate of return. The last one should be the internal rate of return. So the last one I want us to discuss should be the internal rate of return. Internal rate of return, or the IRR. We now look at the internal rate of return, or simply the IRR. That one is the number 5. Yeah, so let us now discuss about that IRR and see what we can also get from the IRR. So for the IRR, we note that it is the required rate of return. It is the required rate of return where NPV is equal to 0. It is the required rate of return where the NPV would be equal to 0. Where the NPV would be equal to 0. Where the NPV would be equal to 0. Then we continue by writing that the decision is normally made as follows. 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 So Roman letter 1 is that if IRR is greater than cost of capital, then accept the project. If the IRR is greater than the cost of capital, then accept the project. Then we accept the project. The Roman letter 2 is that if IRR is less than the cost of capital, if it is less than the cost of capital, we reject the project. We reject the project. Then number 3 is that if IRR is equal to the cost of capital, if it is equal to the cost of capital, then we can either accept or reject the project. We can either accept or reject the project. We can either accept or reject the project. Then another paragraph summarizes that IRR can be computed IRR can be computed using different methods. IRR can be computed using different methods, depending on nature of the cash flows. Depending on the nature of the cash flows, or the economic life of the project, depending on the nature of the cash flows or economic life of the project as follows. Or the economic life of the project as follows. Or the economic life of the project as follows. The economic life of the project as follows. The economic life of the project as follows. The economic life. Economic life of the project as follows. So we start with the A will be in the case of annuity. In case of the annuity cash flows. So A we can talk about in case of the annuity cash flows. When cash flows are annuity, how do we calculate IRR? So under that, we shall first summarize that at IRR, NPV is equal to 0. At IRR, NPV is equal to 0. At IRR, NPV is equal to 0. Therefore, present value of the cash inflows will be equal to present value for the cash outflows. Therefore, the present value for the cash inflows will be equal to the present value for the cash outflows. Then we continue by writing that in this case, IRR will be expressed as follows. In this case, IRR will be expressed as follows. IRR will be expressed as follows. So to calculate our IRR, we will be expressing it as present value interest factor for the annuity R% and R% and should be equal to the present value of the cash outflows. Then you can divide by the annuity. So to calculate our IRR, it will be present value interest factor for the annuity at R% in N. So it should be present value for the cash outflow. We divide by the annuity. So we will be given the initial cost, which is the present value for the cash outflow. You will also be given the annuity. So once you divide, the figure you get will be rounding it off to 4 decimal places. Then N will be given. N will be given. So you go to the second table along period N. You move across until you get the figure you have calculated. That will be our IRR. So I will give you first an illustration to see how we can go about to compute the IRR. So we can write down this illustration by summarizing that. Consider consider the following two projects with the following features. Consider the following two projects with the following features. Consider the following two projects with the following features. Consider the following two projects with the following features. With the following features. So we can have the column for the projects. Then also the column for the initial investments. Initial investment. Then also we can have the annual cash flows. And apart from the annual cash flows, there is also the project life. There is also project life. So we have the project initial investment, annual cash flows, and also the project life. So there is project A and B. There is project A and B. So project A, initial investment is 15 million. Then annual cash flows for project A, it is 3,286,800. So the project life for project A, it is 7 years. So for project B, it is 30 millions. 30 millions. Annual cash flows is meant to be 8,141,141, then 760. The economic life is supposed to be 6 years. So required is that compute the IRR for each project. 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 So to calculate the IRR, I'll start off with project A. I start off with project A. So when it comes to project A, it is that present value interest factor for the annuity, our percent in period 7 should be equal to present value for the cash outflows divided by the annuity. So our present value for the cash outflow is the initial cost, which is 15 million. Then divide by the economic life, 286,800. So that figure, I want you to round it off to 4 decimal places. That figure you get, I would like you to round it off to 4 decimal places. I'd like you to round it off to 4 decimal places. So when you round it off to 4 decimal places, it should give us it here. 4.56. round it off to 4 decimal places. 5637. So I want you to go to the second table. Check in the second table, period 7. Check in the second table, period 7. What are your second table for the present value tables? So go to period 7, move across until you get the figure you have just calculated. Then you check up, it falls under what percent? 7. So IRR will be 12%. So there's a small variation there, isn't it? Yeah, but the difference is not much. Because this one is 4.5637. The one in the table is 4.5638. Yeah, so just assume it is 12%. So when you check up, you will see the 12%. So online, you can be able to see how to get that IRR. So the IRR is going to be 12%. So that's now for project A. Then we go to project B. We now go to project B. When it comes to project B, also present value interest factor for the annuity R% for 6 years. So you also take present value for the cash outflow divided by the annuity. So you take that millions divide by 8, 141, 760. So that figure also round it off into 4 decimal places. Then you go to period 6. Then you check up. It falls under what percent? Go to period 6. We check up. It falls under what percent? It is 16%. Yeah, so that one you indicate IRR will be 16%. The IRR will be 16%. So I want us now to go to your past papers. We check a question for November 2015. November 2015. Question number 3, part B. November 2015, question number 3, part B. November 2015, question number 3, part B. So we are already checked on the question, November 2015, question 3, part B. So they normally start with May, they go to September is almost, not September. This one in November, so not September, November 2015. November 2015, question number 3, part B. You can see the question where they say that the following details relate to a capital project in XYZ Limited. So project cost, you can see 65 millions. Then annual cash flows 21 millions. Then economic life is given us 5 years. So required. Assess the suitability of the capital project using the following methods. You can see Roman letter 1 is IRR. So we want to see how to apply the IRR in order to assess whether to accept the project or not. We want to apply that portion. So have you been able to see that question? So you want to compute the IRR of the project. So to calculate the IRR, it will be present value interest factor. The present value interest factor for the annuity at R% in period. So this one, there are 5 years. These ones, they are meant to be 5 years. So it will be present value for the cash outflows divided by the annuity. The present value of the cash outflows divided by the annuity. So present value for the cash outflow is the project cost. Right, by given 65 million. So divide by the annuity. The annuity is the annual cash flows, which is 21 million. So that figure, you round it off. We round it off to 4 decimal places. We round it off into 4 decimal places. And check, it is not exact, it is between some percentages. It is not exact, it is between some percentages. So it is between which percent and which percentage? So then 16 and 20. Yeah, so it is between 16 and 20. So I would like you to confirm for me, when it is 16%, what do you get in the table? 16% in year 5 in that table. Which value do you get from the table? Sorry? 2743. So in between is the IRR. The one for the IRR is what you calculated. The one that you calculated up there, it was which figure? 09 52. Then when it is 20, nine, like that. Yeah, so it is in between. The IRR is between 16 and 20, but we need to get the exact. So to compute the exact, we shall express it in this manner. When you want to get the exact, we shall say that we take the IRR, subtract 16. You also take 20 minus 16. So the figure I'm supposed to get, I've only used this one. It is like the gradient. Change in y divided by the change in x. So assuming 20 and 16 is our x, then IRR and 16 is our y. So it should be the same figure that you should get when you use these values. So when I'm using these values, I start again with the one for IRR. The one for the IRR is 3.0952. I subtract the one for 16, 3.2743. We also divide again by the one for 20 is 2.9946. Also minus 3.274. So once you do that, it will be the same as IRR minus 16 divided by 4. It is the same as IRR minus 16 divided by 4 should be equal to So 3.0952 minus 3.2743 is negative 0.1791 like that. We also divide by, also take 2.9906 minus 3.2743. Negative 0.2837. So I want you to cross multiply those items and make IRR to be the subject. So cross multiply this, make IRR to be the subject. So I would like you to cross multiply, then finally make IRR to be the subject. So you can cross multiply and make the IRR to be the subject and see it should give us which value. So we are getting which figure? 18.53. So online you are getting which value? Online, when you cross multiply, what should be your IRR? 18.53. So you advise them to accept the project. The advice is that accept the project since the IRR is greater than the cost of capital. You advise them to accept the project because IRR is greater than the cost of capital. IRR is greater than the cost of capital. So that is now in case of the annuity cash flows. In case of the annuity cash flows. So we can go to B. Was it B or number 2? Where we started? How to calculate the IRR. Ya kwanza ni number 1 or number A? Oh, so that was A. So we go to B. So B will be in case of non-conventional cash flows. Non-conventional cash flows. In case of the non-conventional cash flows. In case of non-conventional cash flows. So I will be explaining what we mean by non-conventional cash flows and how can we also calculate the IRR when the cash flows are non-code. So we can summarize that these are cash flows which keeps on changing. These are cash flows which keeps on changing. They are cash flows which keeps on changing, i.e. at one point they are positive, i.e. at one point they are positive, and at another point they are negative. At one point they are positive, and at another point they are negative. They are negative. Then we continue by noting that in this case, the project normally have 2 IRR. In this case, the project normally have 2 IRR. In this case, the project normally have 2 IRR. The project normally have 2 IRR. Then we continue by writing that to compute the IRR, to calculate the IRR, comma, we use the quadratic equation. To calculate the IRR, we use the quadratic equation. We use the quadratic equation. So to compute the IRR, we use the quadratic equation. So I'll give you a brief illustration to see how to calculate the IRR. So we can have an example by noting that consider a 2-year project. An example. Consider a 2-year project. Consider a 2-year project whose initial investment is 1,000. Whose initial investment is 1,000. Whose initial investment is 1,000, and it is expected to generate the following cash flows, and it is expected to generate the following cash flows, and it is expected to generate the following cash flows. It is expected to generate the following cash flows. So we can have the year and also the cash flows. So year 1, we can have it as 1,000. Year 2 as negative 3750. So the year and also the cash flows. So you can have it presented in that. So now required is that compute the 2 IRR of this project. Compute the 2 IRR of this project. Compute the 2 IRR of this project. So you compute the 2 IRR of this project. So to compute the 2 IRR of this project, we shall be saying that at IRR, NPV is equal to 0. So we have seen that at IRR, NPV is supposed to be equal to 0. So for the NPV to be equal to 0, it means that present value for the cash inflows will be equal to the present value for the cash outflows, because the difference is NPV, which is 0. So for the NPV to be 0, it means present value for the cash inflows should be equal to present value for the cash outflows. So we start off with year one. So year one, it is 4,000, then 1 plus r raised to the power of negative n. So year one, n is -1. Then we add, year two is -3750. Then 1 plus r raised to the power of -2. So initial cost was 1,000. That was the present value for the cash outflow. So at IRR, NPV, so present value for the cash inflow should be equal to present value for the cash outflow. You remember the figures in the first table. It is 1 plus r raised to the power of negative. So r is what we are looking for. So we don't know the figure. R is what we are looking for. We don't know the figure. Then we shall also be able to say that we let x be 1 plus. Sorry, before then, I can first remove the negative signs. I will first be able to remove the negative sign. So any figure which has a negative and you make it to be a denominator, the change to be positive. So this will be the same as 4,000, then 1/1 plus r. So n is still n now turn out to be 1 plus -3750, then 1 plus, sorry, 1 divided by 1 plus r. So n 20 to be equal to. So to remove the negative, the figure in brackets will take it 1 divided by that value. Then we shall also say that let x represent 1/1 plus r. We also say that let x represent 1/1 plus r. So this now will be the same as 4,000 x plus -3750x squared should be equal to 1,000. So we also say that we let x be 1/1 plus r. We shall also say that let x be 1/1 plus r. So once you have done that, we need to arrange that information in a quadratic format. We arrange the information in a quadratic format. So quadratic equation is normally ax squared. You add b x plus c should be equal to 0. So I arrange this information in form of that. So where there is x squared, it comes first. So it will be -3750x squared plus. So this one is only one x, it will be x. So 4,000 x. So this 1,000 is our c, but it has to cross it. When it crosses, it becomes negative. Minus 1,000, it should be equal to minus 1,000. It should be equal to 0. Then also, we simplify this because there are two units. The least common multiple will be 250. 250 can go to all of them. the lowest figure that can go to all of them. So when you take negative 3750 divided by 250, so that would be negative 15x plus what? 16x minus what? Minus 4 should be equal to 0. So the implication there is that A is negative 15, B is 16, so C is negative 4. So C negative 4 from this equation and attach it to that, because A is now 15, B is 16, C is the 4. So I hope you remember your quadratic equation. Unakumbuka quadratic equation. X is supposed to be equal to what? So X is supposed to be equal to, was it plus or negative? It is b squared minus or something of that. Square root of what? Then this one is not b squared. So this one is b squared minus 4s divided by 2. So now we create the equation x should be equal to, so minus, so b is 16, then plus or minus, so 16 squared minus 4, so that is negative 15, b is negative 4. Then you divide by 2, negative 15. So you compute the 2x, calculate the 2x when it is positive and also when it is negative. We calculate the 2x when it is positive and also when it is negative.
So basically, now we are assuming the basic of that. Then begin for another 20 years. The last thing that we need to compute now so this now has the 10,000 multiplied by 8 and 10,000 divided by 2,000 divided by 6
So one of the x you are getting it here. One of the x is 0.4. Online you are getting those figures. The other x should be the same as 2/3. So it is recurring. When it is 0.6 recurring, as a fraction is the same as 2/3. The other one was exact 0.4. But when it is recurring, 0.6 recurring is the same as 2/3. So online, I hope you are getting those figures. Tumepata those values of x. You speak your mind. If you are not getting, you let us know so that we see what we can assist. So everyone is getting those figures. Saying you are saying it is 0.6. They are saying it is not. Oh, am I referring to the 0.6 recurring? So those are the two values of x. Those are the two values of x. But we had said that x is equal to 1/1 plus r. You remember that? Yeah, so we are looking for r. We are looking for r under each one of them. So the first one, when x is 0.4. So 0.4 is the same as equal to 1/1 plus r. Because x is equal to 1/1 plus r. So when it is 4, we say 0.4 should be equal to 1/1 plus r. So we make r to be the subject in that equation. So making r to be the subject, when you cross multiply, will be 0.4 plus 0.4 R should be equal to 1 because we make R to be the subject. When you cross multiply, it will be 0.4 multiplied 1, also 0.4 multiplied R. So making R to be the subject. So 0.4 R should be equal to 1 minus 0.4. So 0.4 R is the same as, so R this one is 1 point. Yeah, so which means it is the same as 150% because when you express it as a percentage, so R will be 150%. Then we repeat the same for the other value. We repeat the same for the other value. So we repeat the same for this other value, whereby X is supposed to be equal to 2 over 3. So we also said 2 over 3 should be equal to 1 over 1 plus R. Also cross multiply and make R be the subject. Also cross multiply, make R to be the subject. Make R to be the subject. So 0.5, which is the same as 50%. So 0.5 is the same as 50%. So you're preparing for 50%. Does it have 50%? It has 30%. So that's now the two IRR. One is 150%, the other one should be 15%. Those are the two IRR of the project. So apart from that, there is a similar question in your past paper. There is a similar question in your past papers. So this one was the pilot paper. I want you to check December 2021, the one for the pilot paper. December 2021, pilot paper, question number 1, part B. There's a question for December 2021, a pilot paper, question number 1, part B. Question number 1, part B. The pilot paper for December 2021, question 1, part B. So that question 1, part B, they were able to give you information that Mountain Mall Limited is considering a project with the following cash flows. So they have given us end of the year. So year 0, you can see negative 40,000. Year 1, it is 100,000. Year 2, it is negative 20,000. So additional information, the firm's cost of capital is 15%. The corporate tax rate is 30%. So now required from letter 1, compute the two IRR associated with these cash flows. They would like you to calculate the two IRR associated with the cash flow. So from what I've shown you, there is no need of you going to actually into more details. We just arrange it in a quadratic way. A quadratic way was that x squared should be equal to bx plus c should be equal to what? So that is now the quadratic format. So in this question, year one, they gave us how much? No, I'm asking before I go back to that. Year one, they have given us. So it is 100,000 x. So how to get to x? Yeah, we don't go back to formulate the way I've done the other questions. We know year one it is 1 over 1 plus x over 1 over 1 plus r, which I said the same as x. Then year 2 I'm a pair negative what? Negative 20,000 x squared. Like that. So it is supposed to be equal to year 0, I'm going to pay 40,000, which is negative. So it is negative because it is an outflow. So don't write there as negative. Just write it as 40,000 because it is what? Outflow. That's why they have put it there negative in year 0. It is an outflow, not an inflow. Then, now when you formulate it as a quadratic equation, it is the same as negative 20,000 x squared plus 100,000 x. Now this one will cross become 40,000 should be equal to 0. Should be equal to 0 like that. Then you need to simplify that further because those figures are too huge. 20,000 can go to all of them, isn't it? So 20,000 can go to 20,000. How many times 1? So this one will be negative x squared. Negative x squared plus. Here you get 5x minus 2 equal to 0 like that. So we know A will be negative 1. B is 5. C will be negative 2. C will be negative 2. C will be negative 2 in that order. So now you apply the formula I've given you. X is supposed to be a squared minus 4ac divided by 2a. So now x should be equal to negative. So b we have said is 5 plus or minus. So 5 squared minus 4. So there is negative 1. C is negative 2. So we have not been prospecting because in the but now, in reality, we are thinking of it. The possibility is what we expect within the action. The second possibility is so get the two values of x when it is positive and when it is negative. So we get the two values of x. The expected is less than half. So this one creates what we call floating cost. What we call it that. This now in a given what we call Once you get the two values for x, you also use the formula that x is supposed to be equal to 1 over 1 plus r. Then in that equation, you make r to be the subject. In that equation, we make r to be the subject.
So you have avoided the opening course. Then we have so we avoid the opening course. But however, when it's exposed on the other side, I will never be still. I always want. The guys who do that. So there I mean, you never you can't help it. Anytime money is needed, but now it's exposed to only one.
So one of the x must be negative. And then a positive. So I'm getting negative what? Let me express it as a percentage. The figure you have calculated, I said you express them that way. X is equal to 1 over 1 plus r. Then you make r to be the side. So when you express it as a percentage, negative 78, another one 128. Yeah, so those are the two IRR. The two IRR, one is meant to be negative 78 when you express it as a percentage. Another one is a positive one. It is 127 point something, but when you round off, you will be 128. So that is now how you will be able to calculate the two IRR. So after you have done that, you are meant now to answer the Roman letter 2. So Roman letter 2, they asked that if the firm's cost of capital falls between the two IRR, if the firm's cost of capital falls between the two IRR values, calculated in being Roman letter 1 above, advise the firm on whether to accept or reject. So the firm cost of capital up, they can say 15%. Yeah, so the 15% is between negative 78 and 128. So any moment it is in between, we normally accept the project. So we advise that since the cost of capital is between the two IRR, since the cost of capital is between the two IRR, then accept the project. Since the cost of capital is between the two IRR, then accept the project. Then accept the project. Then accept the project. So that is now in case of non-conventional cash flows. Then we are also going to see C should be that in case of unequal cash flows. Another way on how to calculate IRR. Another way on how to calculate the IRR. Also, so in case of unequal cash flows. Unequal cash flows. In case of the unequal cash flows. So when it comes to unequal cash flows are not the same. So how do we compute the IRR? So we summarize that in this case, IRR is calculated. In this case, IRR is calculated using trial and error method. We use the trial and error method. IRR is calculated using the trial and error method by adopting the following steps. By adopting the following steps. By adopting the following steps. So step number one is that compute the NPV of the project. Compute the NPV of the project using the cost of capital given. Compute the NPV of the project using the cost of capital given. Compute the NPV of the project using the cost of capital given. So that will be now our step number one. We got the step number two. So number two, there are two of them. We can start with the 2A. We start with the 2A, step 2A. So under step 2A, you also note that if NPV obtained in step 1, if the NPV obtained in step 1 is positive, if the NPV obtained in step 1 is positive, then rediscount the cash flows again. Then rediscount the cash flows again. Then rediscount the cash flows again using a higher discounting rate. Rediscount the cash flows again using a higher discounting rate. Using a higher discounting rate, which will give a negative NPV, which will give a negative NPV, which will give a negative NPV. Then the step number 2B, step 2B, we also note that if the NPV in step 1 is negative, if the NPV in step 1 is negative, if the NPV in step 1 is negative, comma, then rediscount the cash flows again. Then rediscount the cash flows again. Rediscount the cash flows again using a lower discounting rate. Rediscount the cash flows again using a lower discounting rate. Using a lower discounting rate, which will give a positive NPV. Using a lower discounting rate, which will give a positive NPV. Which will give a positive NPV. Which will give a positive NPV. Then step number 3 is that the IRR will then be expressed as follows. The IRR would then be expressed as follows. The IRR would then be expressed as follows. So now this is the formula on how to get the IRR. So IRR will be equal to, you start with the lower discounting rate. Then we add in brackets NPV of the lower discounting rate. You also divide by NPV of the lower discounting rate. We minus NPV of the higher discounting rate. Then higher discounting rate minus the lower discounting rate. So to get our IRR, we simply take lower discounting rate. This one is lower discounting rate, N plus in brackets, NPV of the lower discounting rate. We also divide by NPV of the lower discounting rate minus NPV of the higher discounting rate. Then in brackets, higher discounting rate minus the lower discounting rate. So when you want to get the IRR, we now simply come up with the lower discounting rate plus in brackets NPV of the lower discounting rate. Divide by again NPV of the lower discounting rate. We subtract NPV of the higher discounting rate and higher discounting rate minus the lower discounting rate. So we shall use the question for May 2021, question 1, part B, but we cannot do it now because time is up. So when we meet in our next class, we shall do the question for May 2021. May 2021, question number 1, part B. We had already done the question today under the NPV. So we shall be able now to do the question to answer the IRR. So we cannot do it now. We shall stop there. When we meet, we shall now do the question.